Hi, my name is Mackenzie, and today we're talking about geological features, specifically how toadstools are formed. So, what is geology? Can anybody in the audience tell me what geology is? Yes.
Rocks.
Perfect. Yeah, so geology is the study of rocks and how they are formed. Next, we're going to discuss what is a toadstool. Can you tell me what a toadstool is?
Mushroom rocks.
Perfect. Yeah, so a toadstool are these mushroom-shaped rocks. They are also a type of hoodoo, and they usually form because of differential erosion. Now, what is differential erosion? Well, it's when some rocks are more easily erodible than other rocks. In this case, we have two rock layers. The top layer is much more resistant to erosion, which causes it to stay the same sort of shape, while the bottom rock erodes much faster and keeps getting smaller and smaller while that top rock stays the same. And that's why we get this kind of awkward size difference between the two. And what makes something more or less resistant to erosion? Well, we like to look at how easily water and wind can get in. Are there any air pockets, cracks, or fractures? And then different minerals in the rock can be resistant to erosion. For example, granite contains quartz, and quartz is a very hard mineral, and water cannot get into it to erode it. On the other hand, we have limestone, which contains clay, and clay is very porous and easily penetrable by water. And then lastly, we like to focus on clast size or the grain size inside the rock. Larger clasts or grains are strongly cemented together, while smaller clasts are poorly cemented together. And moving on, we're going to talk about toadstools from all over the world, starting right here in our backyard, Utah. And these you can see north of Page, Arizona, and south of Kanab at the Toadstool Trailhead. There are also toadstools in Goblin Valley State Park, but we're just going to focus on these ones. And they are a combination of Dakota sandstone and Entrada sandstone. And Entrada sandstone is formed from sand dunes that were deposited during the Jurassic period, while the Dakota Formation is composed of sandstone, mudstone, and shale. And this more resistant to erosion sandstone was formed during the early Cretaceous period and was deposited in the Western Interior Seaway. Now, what is the Western Interior Seaway? Well, it is this sea that filled the middle of our country, pretty much the middle of the whole entire continent, not including South America. But this giant sea deposited this layer of minerals that is now the Dakota sandstone. And you will see it in many states, including the state that we look at in the next slide. And again, Dakota sandstone is resistant to erosion, and big grains are strongly cemented together, causing this top to stay this way. While the Entrada sandstone is the old sand dune deposits that are now cemented together very poorly, and they are now the skinny little bottom layer that we see eroding today. Moving on, we got the Kansas toadstools. These are located in Mushroom Rock State Park. And again, we see our Dakota sandstone, which covers the entire area, again, deposited by the Western Interior Seaway. And these are special because they only contain one type of rock, the Dakota Formation. Well, how is that possible? Well, when this rock layer was still underground, minerals in the groundwater chemically altered the top rock, causing it to be better cemented together with calcium carbonate. This caused the top layer of the Dakota sandstone to be harder than the natural Dakota sandstone layer that is lighter that we see today. And it also caused this change of color between the top layer. Here we see it became much darker with the calcium carbonate than the bottom, which is still the natural Dakota sandstone. Pretty neat. Who would have thought Kansas had cool stuff? Next, we're going to talk about Nebraska. These are located in Toadstool Geologic Park. So we have the top layer, which is the more resistant Orella sandstone, and it is formed from an old sandbar in a river 30 million years ago. And below that is the Chadron layer, It's a softer siltstone and erodes before the sandstone, again causing these mushroom-like features, and these tend to be a little bit more abstract looking in shape due to the different layers that we see here. Next, we have Romanian toadstools. So I could not find much about the geology of this location, but we did find out that Babel means old women, because apparently these look like old women, and they are made of sandstone and limestone. They are known to Romania as the mouth of heaven. Next, we're talking about Turkey toadstools. These are my absolute favorite. They are also called fairy chimneys, and these are the result of volcanic action. So, the bottom, more easily eroded layer was formed millions of years ago when volcanic eruptions rained ash all over what is now Turkey. The ash hardened into a soft and porous rock, and this makes it easier for wind and water to get inside the rock and easily erode it. The top layer is basalt, which is formed by lava quickly cooling on top of the Earth's surface and forming this hard, well-cemented rock layer that is much harder to erode than the ash layer that we see below it. Now we got Taiwan's toadstools. These are located in Yalu Geopark, and they are made out of sandstone. These are some of the only hoodoos known to form in a seaside environment, which is very cool. The whole thing is made up of the same type of rock, and the colors are chemically altered due to the seawater. And another cool thing to note is that because of the tides coming in and out, you can see that they have eroded the bottom into this really smooth texture, while the top remains this hard, rocky, rough texture. Now we got Egypt's toadstools. These are located in the White Desert. And 80 million years ago, the White Desert was a sea that left this chalky limestone that we see today. This desert has many sandstones, and wind blown above 3 feet off the ground are the strongest. And this causes the bottom to erode much faster than its top, leaving this weird, really cool but weird shape in the White Desert. So let's do a quick review. So toadstools are mushroom-shaped rocks formed by differential erosion. They are a type of hoodoo and form anywhere around the world with an array of different rock types. They are so diverse, come in many colors, many shapes, many sizes, and once you look into them, you realize there's a lot more out there. Now, we're going to move on to a demonstration on how hoodoos are formed. Alright, so here's a very abstract demonstration of how toadstools are formed. So, we have 2 essential quarantine snacks. We have our rice, which is frozen in water, and it's acting as our harder to erode top layer. We have our mashed potatoes, and they're acting as our easily eroded bottom layer. All right, let's make a toadstool, everybody. Plop that on top. This fork is gonna act like the wind erosion that we see with these toadstools. All right, let's start going. All right, and here we can see the top layer is not eroding as easily as the mashed potato layer. And this is a great demonstration for how toadstools are formed due to the fact that the bottom layer is always much softer than the hard, less resistant to erosion top layer. And then, wind takes the deposits away, and we have a beautiful rock formation in the form of basmati rice and mashed potatoes with vegan butter. Thank you for listening to my presentation.